Okay, so that means you have to choose your partners wisely. Okay. All right, so now we are maximizing volume. As soon as we maximize or minimize, this is what goes into my Y1. So right away, I'm going to start like this. Y1 is volume. Volume is length times width times height. I know this is going in my Y1, so I need a length, I need a width, I need a height. I need the 3 dimensions. I take out my corners. Each corner is a square, so it's an x by x. This has to measure 86 right here, but the original thing had 2 pieces over here. Okay, this measured 86 over here, and 55 over here. Sorry about that. And these have 2 pieces that I'm removing. Also, like when we did this, when we removed this x and you lift up this side, there's the height of your box, x. Whatever that is, that's the height of your box. Sometimes it's helpful, try it like I did with you. So you fold up the box, you can actually see it. No lids, so we don't have to worry about any lids or anything. So this side has 2 pieces, 86 minus 2x. This side has 2 pieces, 55 minus 2x. The height is the x. Whatever x is when I fold this little piece up like this, that's the height, x. This goes in your Y1. Do you have to multiply that out ahead of time? No. Leave it in like that in your Y1. I don't care what it looks like in there. All I care about is I'm maximizing. I need to find a turning point. This is my x value. This is my maximum volume. And then once I get it to this part, take your x and plug it into one of these. Find your length, find your width, and find your height. Okay? Probably the hardest part is taking out those sides. Way back I taught 8th grade. When you guys learn solids, you learn the cubes and all those and cones. So I'm not a very good spatial person myself. So I had my kids actually cut out the pieces and fold them up to make the solids. And then we unfolded them to see the pieces, like the faces, to do the surface areas and things like that. It makes much more sense when you actually look at one. Your complete graph is this. This is called the complete graph. This is my situational graph. This is the graph of just what could possibly happen. I can't get negatives in this. I can't get a negative length, negative width, negative height. So I am confined to quadrant 1. But my situation is x times x times x. It's a cubing function. And again, 3 decimals. Go to 3 decimals. This time they wanted to know what is the maximum volume, find the dimensions of the box, and give me the maximum volume. And if you're stuck, these dimensions aren't so bad. Even if you did 86 times 55 times 5 even, if you can't figure out what the height is, times 5, or do something, or 10, or get close enough to estimate a window. Or again, set your table set. Go by 10s, go by 50s, go by 100s, until you see it turn. And again, when you do your window, don't get exact on your window. This is the place you get exact when you do your maps. Your window is just, if I pass a turning point, I'll just estimate it. Can I change it if I don't see it turn? Absolutely. If I'm stuck, I'm going to zoom 6 and start again. Get used to changing those things. Change your table set, change your windows. Get comfortable with that. Questions at all on this? No? Okay. How about the review? Okay, everybody comfortable with completing the square? For this question, because A is 1, and 4 is a nice even number, so everything works well. Just keep the same process, no matter how bad it looks. Now, once you get here, and if you put it on the other side, just move it back to this side. This is where you do your transformations from. This is your vertex form. So your vertex, this comes out the opposite because this is a horizontal shift to the left 4. This is a vertical shift down 5. Keep track of that vertex. Okay, so if anything else happens to it, you know where you are. Now, when you get to here, your axis of symmetry cuts through that x number. X equals, your axis of symmetry is an equation. To find your intercepts, real easy. When you do your y-intercept, when x is 0, go back to the original, because if I plug in x is 0 and an x is 0, what is my y-intercept? 11. When I do my x-intercept, go to this guy. So you're here. We can tell by your graph that you have intercepts. Add 5 and take the square root. Just remember, this is your plus and minus. And then just subtract the 4. You can absolutely go back to this guy and do the quadratic formula if you're stuck. But why go through all that trouble when this is one of the reasons why you put it into vertex form? God bless you. Yes.
Can you do plus or minus for 5 minus 4?
Yes. Yeah. That's fine too. Yeah. That just changes the order. When you do the properties, you're fine. Just leave all radicals in reduced radical form. Leave all fractions in reduced fraction form. That's like kind of the norm. Everybody good with the increasing, decreasing? Okay. Everybody good with this is an absolute? Ladies, absolute minimum? Absolute, right? We're absolutely sure? Okay. Next one. Now, keep the x's together. That's all I care about. I don't care about that 1 right now. But this guy has to be a 1 in front of this. So whatever that is, I'm going to factor it out. And yeah, it's the same routine. I just get a fraction. And that's okay. So I say, okay, factor out my 2. Take 1/2 of that. So I'm going to cut 1/2 divided by 2. If I can't do it, I'm going to do it in my calculator. Just put it in your calculator. 1/2 divide by 2. Just go like that. Put it in your calculator. Flip it back. This says keep, change, flip. It's 1/4. If you kind of visualize a piece of 1/2 and you cut a piece of 1/2 into half, doesn't it have to get smaller? Half of a half is a quarter, right? So kind of visualize that. You're still dividing by 2. Then I square this, and I put this here. In order for me to, excuse me, to subtract it, I have to multiply it out of here, distribute it out of there. I can do this in my calculator. Put that in your calculator. And we come down to a fraction. And it's okay to have fractions. My vertex is at a fraction, and I'm okay with that. My intercepts, again, when x is 0, y is 1. When I get here, I'm going to plug this in. I'm going to plug in a y of 0, subtract my 7/8. As soon as you get to this point, and you have to take the square root of a negative number, you don't even have to divide by 2. Just if you say can't take the square root of a negative number, no real roots. That's all I want you to say. Does that confirm it? Does your graph confirm there it doesn't cross the x-axis? So don't sweat that out. As soon as you see you have to take the square root of a negative number, no real roots. Again, we only work one little time with the imaginary number, and this isn't it. Increasing, decreasing, good? Domain and range, okay? Is this an absolute minimum or a relative minimum? Absolute. It is absolutely the lowest point. Watch those 1/2. Stop me if you have any questions, if it's not answering your question. This one's going to give us a fraction as well, but the process is the same. We say group the x's together. This is a 1. We're good with this. So we take half of 3. Just take 3, divide it by 2. Make it 3 halves. God bless you. Square it. So 9 halves. Put it to this side. This worked itself out nicely, and I don't care because my calculator can do that for me. Put that in your calculator. It worked out pretty nicely. Yeah, you have a fraction here, but that's okay. We can deal with that fraction. So that fraction just puts us, remember, you're sketching. So if it's a little too close to the line, put it a little bit under the line, a little too close to the middle, just get it a little over. As long as you're in the right quadrant, I'm pretty good. Axis of symmetry, your x equals. This again, this is kind of messy looking, but just go step by step. Move the 2, take the square root, move the 3 halves. Excuse me, this is exactly what you would get if you did your quadratic formula on this. Intercept is nice. Just show me substitution. I didn't show the substitution, but you should just show me the substitution. Just go like this. Just give me substitution. Confirm it on your calculator. Confirm it. Do a minimum and make sure everything is okay. Well, this you might not have your calculator for.
On the test.
Did this say no calculator?
Yeah.
Yeah. I mean, do you actually need to pick up the calculator?
Just use it to check.
To check it. And really, a calculator doesn't kind of help you anyway. I'll look at it and see. I mean, because you have to work all those pieces out anyway.
Are we going to use a calculator on the test?
I can't remember, but if it's just this, I would probably say calculator isn't going to help you anyway. Yeah, to do your fractions, it'll help you. Let me take a look at the test.
No, it's a check.
I think we said that's true too. Make sure you get 100. I mean, because the calculator really isn't going to help you solve the rest of the inside part anyway. So let me take a look at it. Let me look it over. This is a tough group. Okay. All right. This one, it has a -1 sitting out in front of there. One of the biggest mistakes is trying to factor with a negative in front, even just a regular set of factors. Always factor out that -1. What does that make your parabola do? Go down. It turns it down. So factor out that -1 to start, and then you're good. Leave a little space. You're still subtracting. Just be careful when you come out here. You're subtracting a -4. When you subtract a negative, it's a positive. So I get my vertex. I see it turn down. My intercepts. My domain and range. Watch the bars on your domain and range. If it includes the point, you need a hard bracket. Last test, I just kind of drew over your brackets. Because I know you're still adjusting to the domain and range. God bless you. Is that getting easier, domain and range, for you guys? Right? It does. As soon as you get a little bit more comfortable with it, it's like second nature. We can see that we have roots. What's good about finding this before you sketch it is I can approximate this. This is a little bit more than a 4, so it's a little bit over 2. So if I add a little bit over 2, it actually puts me to the other side of this just a little bit. And then 1 puts me on the negative side. But you're close enough to that, rather than make it narrow. Okay. This was the easy part. It's kind of just get into the routine, know what steps to do, and you should be good. Did you have a number 5?
Yeah.
Okay. Okay. Now, you like the fact that this piece is good in here. Be careful of this 2. If you want to take this 2 out of that parentheses, and you just want to deal with your x values, which what I would do, I would take this 2 and get it out of there like we do in the other ones. Just remember this has to be distributed out. You can keep it in here, Complete the square inside if there's a big parentheses, but don't forget then you still got the 1/2 outside. So me, I like to get rid of this guy. In fact, if you just distribute it out and keep it out here, and then deal with your x's, it's already perfect for you to do your x's. 1/2 of 4. Just be careful when you distribute this back out. What does this 1/2 do? It makes it wider because this is a vertical shrink. It shrinks the distance to 0. So technically it looks like it widens it, but it's actually shrinking the distance to 0. Graph this with your vertex, axis of symmetry. Again, your x's, plug in here. Be careful of your x's this time. This x is 0, 0, unless you go back to this one. This is 0, 0, but a negative 1/2, a 1/2 times a negative 2. Be careful of that. Your intercepts. Everybody good with increasing, decreasing? You know to give me your x values? Yes.
Shouldn't the vertex be -3?
-3. That is a little negative there.
Oh.
Sorry. That is a little, looks like a smudge. Yeah. It's there too, somehow. I probably didn't have the negative and went over, and when I realized it, stuck it in there. Good? Questions at all? Okay. I gave you one that you had to figure out, right? Is that on the bottom of that one?
You just do this 2 elements.
That's a 5B. That's okay. Try that now. Try 5B. So what should we do first? Plug in the vertex. Makes the most sense. H and K. So plug in your vertex. A is the one that's going to give you a little bit of trouble, but everything else should be okay. Then what? We need to find the A. It's almost there, but we need to find the A. Plug the points in. I'm giving 2 points here, an X and a Y. It's the same thing when you guys do this, MX plus B. And you're given 1 point, I'm giving you a point, and I'm giving you a slope. So you plug in your slope, and then you plug in your X and Y, and you find B, right? And then you just put it back into your equation. It's the same exact thing. So now plug in your X and Y. And just solve for A. So what does A come out to be? 1? Okay, and just remember to just go plug it back in. Okay? All right, so tonight you have the other half of this.